Okay, so today what we're going to look at are some SAT math strategies. And remember, the SAT math categories, they have topics on algebra, topics on geometry, topics on statistics, topics on arithmetic, and a little bit like number theory. Now, algebra is one of the more common topics, and we want to see what our primary strategy is to handle algebra questions. Our primary strategy to kind of combat any difficult questions will be what we call plugging in. What plugging in is, it's a strategy that allows us to turn any algebra question, whether it's easy or hard, into a more straightforward and easier question, because it kind of turns it into an arithmetic-based question, which we've been doing, since elementary school, compared to doing algebra since middle school, maybe even high school. So we're just kind of inherently better at that, arithmetic, than we are at algebra. We can use this strategy when we see variables in the answer choice. That's the biggest giveaway. There are some other cases in which we can use algebra as well, or plugging in, but variables in the answer choices are the biggest giveaway. Now, just to be clear, all these questions, of course, can be solved algebraically, but if you get stuck, that's when plugging in is the valuable strategy to you. It gives you an alternative method to do it when your algebra knowledge is just not kind of cutting it or confusing you, or some other scenario where you just don't like the algebra. It's an alternative method. The more methods you have to use, better you are going to be at the test. So let's look at number 8 and kind of see how this plugging in strategy occurs, or how it works. So number 8 says, while driving on a 500-mile trip, Mr. Smith averages 60 miles per hour for the first t hours. In terms of t, where t is less than 8, how many miles remain to be traveled? So we see the variables in the question, we see variables in the answer choices. That's the giveaway that we can use plugging in. What we want to do is, when we see these sorts of questions, we want to kind of take a step back and first treat them like stories rather than actual algebra questions. So Mr. Smith wants to go 500 miles away, and for a few hours he's going to travel 60 miles per hour. We can choose any number we'd like for t, and we should. Now, they give us a rule, though, that does restrict some of our choices. The t must be less than 8. So let's choose a t that's less than 8. How about 4? It's a pretty easy number. The entire point of plugging in is to make our lives easier. You choose easy numbers for yourself. So he's going to travel for 4 hours at 60 miles per hour. So how far did he go? Well, 60 times 4, 240. He went 240 miles. The question's asking how many miles remain on his trip. So we should go ahead and find how many actually remain. Well, if he wanted to go 500, and he's already gone 240, then the number of miles left would be 260. Now, if the answer choice is A, B, C, D, E, we're going to have real numbers. That's the number they would have in it, a 260, because that is the answer to the question. But this was supposed to be an algebra question, so they don't have them in real numbers, but we can convert them into real numbers. So we take the t equals 4, we plug it into each of the answer choices, and we're going to look for 260. We have to check all 5. We'll understand why we check all 5 later, but we have to check all 5. 60 times 4, we said that was 240, so A is 240 minus 500. That's negative 260. It's close, but it's not what we're looking for, so no. B is 500 minus 60t. Well, we said 60t is 240, so 500 minus 240. That's 260. That is what we're looking for. It's very promising. That's the answer. Remember, we have to check all 5, so we'll come back to it. 30,000 minus t. Well, you probably don't even need to do the math. If the t is 4, that's a huge number. But what it is 29,996. Definitely not 260. D, 500 minus 60 over t. Well, that'd be 500 minus 60 over 4, which is really 500 minus 15. So 500 minus 15 equals 485. Again, still not the 260, so not D. E, 500 divided by 60 times t. We've seen that a few times. We said 60 times t is 240. So 500 divided by 240, it's about 2. It's a little bit bigger. Either way, it's not a 260, and that's what we want. So the answer has to be B. It's the only one that gave us the exact answer. But none of that required algebra. We did multiplication, we did subtraction, D had us do a little bit of division. None of that was algebraic. It was all arithmetic. And that's the value of plugging in. It can turn what would be a hard question for you into a far easier question. So it is one of our most powerful strategies for the SAT math. Let's kind of continue to understand it. Let's go to a couple others. Again, the giveaway is when there's variables and an answer choice. So number 15, we see variables in the answer choice. That's probably a decent sign it's going to be a plugging in question if we want it to be. So let's go ahead and read it. If a and b are positive integers and 9 times 3 to the a equals 3 to the b, what is a in terms of b? One of the things we can do now that we're not focusing on the algebra is we can ignore phrases like in terms of b if we don't like them. So ignore that. The question is really, what is a? Well, we see variables. When we see variables, we can plug in. Let's choose an a or a b. You could choose either one. Given this, it's probably a little easier to choose a. Again, part of the goal is to keep the numbers simple. So let's keep our life simple, make the a easy. A would be 2 is an easy number. So really the question is saying 9 times 3 to the 2 equals 3 to the b. Well, that really says 9 times 9 equals 3 to the b. 9 times 9 is 81, so 81 is 3 to the b. Now, I don't get to willy-nilly choose what b is. B has to be based on that statement. I can't break the rules of the question. So 3 to something equals 81. Well, you could prime factor it, or you could just times 3 a few times until you get an 81. Either way, you'll be eventually able to figure out what b is. 3 times 3 times 3 times 3 does equal 81. So how many 3's did we have? What would the exponent be? Well, the b should be a 4. So when b is 4, then 3 to the 4th equals 81. So by plugging in an a of 2, that forces the b to be 4. Now what the question's asking for, remember, was a. So that's what you're looking for in the answer choices. You always look for what the question is asking for. So look next to the question mark. So what is a? Well, we're going to look for 2 in the answers when the b is equal to 4. So a says 4 minus 2. That's 2. Might be a. Got to check all 5. B says 4 minus 1. That's 3. So no. C says just b, which we said was 4. So no. D says 4 plus 1. That's 5. That's still not 2. And E, 4 plus 2. That's 6. Still not the 2 that we're looking for. So it has to be answer A. Again, possibly a simpler question if you're not comfortable with exponent rules and the algebraic way of doing this. You still need to know exponent rules to handle it, but it's simpler than it would be. So when you get stuck, it's an alternative strategy. Notice one of the things we saw here. Sometimes when you choose a letter, it forces another letter. So you have to make sure that when you're choosing numbers, it doesn't force other letters first. Sometimes you'll be able to plug in for the A and the B and the C, whatever letters they bring up. It'll always be your choice. Other times they force one another. So just take it gradually, take it slow, and you'll be good. Let's look at another complicated question that might be difficult algebraically for some people, and how plugging in can simplify it. So it says if x is greater than 0, then that whole mess. Well, there's certainly an algebraic way to do it, and you can get to the answer through it. Let's assume we don't know it. Let's assume we want to do it plugging in. The only rule is x needs to be greater than 0. So again, we want to make our lives easy. Choose small numbers typically. You could choose 2, you could choose 3, 4, those probably all work. Let's go with 3. We haven't seen a 3 very often yet. So the equation really says 3 times 3 squared over 3 squared minus 3 squared over 3 squared. That's really 3 times 9 over 9 minus 9 over 9. Well, 9 minus 9 minus 9 over 9, that's just going to be 0. They'll cancel out, right? So it's really saying 3 times 0. So it's be parentheses. 3 times 0, that's 0. So this whole equation actually turns into a 0. So you'd go to the answers looking for a 0. A is a 0, B is a 1, C is an x, which we said was 3. That's not 0. D is 3 squared, that's 9. That's not 0. E is 3 minus 1, that's 2. That's not 0 either. The only one that matched was answer A. So again, it simplifies the question if we don't know the algebra options. A few plugging in tips to make sure that things go well. Choose easy numbers for yourself. We chose things like 2, 3, 4 in the last few questions. 5 is a good number, 10 is a good number. Kind of depends on what the question would be, but easy numbers for yourself. We're not going to choose 0 or 1 unless we have to. We'll see why in the future, but those are kind of special math numbers, and they create some difficulties for us. And similarly, we're not going to choose numbers already given in a question. And we have to check all 5 choices every time that we do plugging in. Let's make sure we master this before we kind of run into why those last 3 rules exist. You can do it even on the grid-in questions where you don't have multiple choice answers. Plugging in actually still works. So 17 here. When the positive integer n is divided by 6, the remainder is 2. What is the remainder when 24n is divided by 36? Well, there's no answer choices, but there's still variables, and that's the sign you can plug in. Choose an n that meets the rules they gave. So it says that the n, when you divide it by 6, has to have a remainder of 2. So what's a number that does that? Well, n can be 8. 8 divided by 6 goes in once with a remainder of 2. So I'm allowed to make the n equal to 8. Anything that meets that statement, I'd be able to make the n. So there's different choices you have. So what is the remainder when 24n is divided by 36? Okay, well 24 times 8, that would be 192. We're going to divide it by 36. So we have calculators in the actual test. We'll do 192 divided by 36. And that goes in just shy of 6 times. If we do 5 times, 192 divided by, or 36 times 5 would be 180. So the remainder is 12. So that's the remainder. That would be the answer you grid in, 12. So plugging in is useful on all the different math questions that deal with variables. Sometimes even the test kind of wants you to plug in, and they'll give you a question like number 12. In the table above, if y equals 2x plus 3, what is the value of b? So they give you the table. Well, they gave us a formula, y equals 2x plus 3. They give us some information, but there's a lot of variables still going on. Since I know that the x in the middle case is a 4, if I plug the 4 into the x here, that should spit out a certain y, which we could call a. So let's give that a try. We could say a equals 2 times 4 plus 3. Well, that's really a equals 8 plus 3, which is 11. So a is 11. Well, if I take that, it says a is also the x column on the next row. So if there's an 11 there, I can plug it in again into the equation, but this time into the x spot, and it should spit out my b. So b equals 2 times 11 plus 3, or b equals 22 plus 3. Or in other words, b is 25, which is exactly what d says. So plugging in occurs in a few different ways. It can occur to simplify questions that were entirely intended to be algebraic. It can occur on grid-in questions, but it's still useful to get to an answer choice. And sometimes even the test has a plugging in mentality, and there's not really many other ways to go about it other than just plugging in what they gave you. So plugging in is a very powerful strategy. We need to be comfortable using it whenever we can. And especially whenever we're stuck, we want to have alternative options of how to approach questions. And that's plugging in, and we'll see why.